Good day, grade 12 learners and teachers. Welcome to today's mathematics lesson. My name is Sibusiso Shongwe, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Right, today we move on to another section of work that would be functions and inverses. But this week, we are just going to focus on revising grade 11 concepts on functions. So today's lesson would be focusing on revision of grade 11 concepts. Next week also we continue revising grade 11 concepts, and then we are going to then do inverse functions. Right, please do not forget that we are available on WhatsApp, and our interactive number is 064-748-8913, 064-748-8913. That's where you can actually post questions. Where you have questions based on the lesson, we will be more than happy to assist you with those questions. Right, let's look at this section of work. Let's look at the lesson objectives first. By the end of this lesson, you should be able to determine the equation of a sketched function, very important. Identify and calculate the x and y intercept of sketched functions. Calculate the average gradient between 2 points. Calculate horizontal, vertical, lengths or distances, and extend your knowledge to maximum and minimum vertical lengths. Apply and use transformations to functions. Solve inequality problems by using graphical approach only. Right, obviously we can refer to our CAPS document as well as the exam guideline on those pages that I've indicated there. Right, let's check the knowledge that you come with to this lesson, because you do not come empty-handed. These are the prerequisite tools that you're supposed to come to this lesson with. Number one would be sketching of a linear function, a quadratic function, a hyperbolic function, and an exponential function with one or more parameters using the dual intercept method. Obviously, the dual intercept method is the method that you use when you calculate the intercept. X-intercept, you put y to be 0. Y-intercept, you put x to be 0. That is the dual intercept method. Right, now the forms of the functions there are, for a linear function we have ax plus q. For a quadratic function we have the two different forms. F of x is a into x plus p squared plus q, and you also have this form, f of x is equals to ax squared plus bx plus c. So you need to be able to work with the quadratic functions in both of the forms. And then you have a hyperbolic function. F of x is equals to a into x plus p plus q, and then you have an exponential function given by f of x is equals to b to the index of x plus p plus q. Now you need to understand, you come to this lesson understanding the effect of those parameters a, q, and p on all the functions. You must know how a affects each function there. You must know how q affects each function. And you must know what p does to all the functions there, or how it affects all the functions there. Obviously, also you come to this lesson knowing what a domain is and what a range is, and knowing how to determine the domain and the range of all the algebraic functions. Algebraic functions, I mean your linear function, I mean your quadratic function, I mean your hyperbolic function, as well as your exponential function. Right. Now, let us dive straight into the examples. We are first going to look at finding equations of all the functions that you studied. We are just going to revise finding those equations. Now, when you look at the first one, the graph below cuts the x-axis at minus 4 and 2 and passes through the point 3 and negative 14. Now the instruction is clear that determine the equation of the following function in the form y is equals to ax squared plus bx plus c. So the examiner here is specific about the form in which he wants or she wants you to leave the answer there. Now, let's look at what is given to us here. If you check this parabola, we are given this as the x-intercept. We are going to call it x1, and we are given this one as another x-intercept. We are going to call it x2. Now, in any quadratic function, if you are looking for the equation and you are given the x-intercept and an additional point, then you use this form. Y is equals to a into x minus x1 x minus x2. This is the form that you are going to use when you want to find an equation of a quadratic function whereby you are given the x-intercepts and an additional point. Now, this x1 and x2, they represent the x-intercepts that you are given. They represent those x-intercepts that you are given. That is very, very important. Now, we are just going to substitute into that formula. Please note, grade 12s, this equation here that is given, this formula that I just wrote, is not in your formula sheet. It is a formula that you need to know by heart. It is a formula that you need to know by heart. Now, let's look at this now. Why you are now going to substitute where you see x1, you are going to put -4. So this is x minus -4 into x minus 2. I just substituted the x-intercept x1 and x2 respectively on that equation there. Now, I also have an additional point. 3, -14. So x is 3, y is -14, because the idea here or the aim is to find the value of a. If you have the value of a there, if you work out the value of a, then it would be easier for you to can then write down that equation. So now, where we see x, we're going to put 3. Where we see y, we put -14. So -14a into x is 3 plus 4. I'm simplifying there, and then 3 minus 2, like that. Now, when you simplify this, you get that this is 3 plus 4, it gives you 7. 3 minus 2 gives you 1. So 7 times 1, you get that this is now 7a is equals to -14. Remember, I got the 7a by adding 3 and 4 to get 7. Then I multiplied 7 with 3 minus 2, which equals 1. So I multiplied 7 by 1 there. So when I divide both sides by 7, I get that a is equals to -2. I will divide uniformly throughout by 7 because I have 7 times a, and I'm not looking for 7 times of a, I'm looking for a. So I will apply that inverse of multiplication there by dividing both sides by 7. So I have that a is equals to -2. Now I'll come back to this form here and substitute all the values. So y will then be equals to, I now know a is -2, x minus x1, I know that's x plus 4, x minus x2 into x minus x2, then that would be x minus 2, like that. So now this would be y is equals to -2 into, I can FOIL this out, x squared. When I multiply here, I get x squared. When I multiply there using distributive law, I get -2x. When I multiply here, I'll get plus 4x. So I have -2x plus 4x. That should give me 2x, which means that I will have now here plus 2x and then minus 8, because I'll be multiplying -4. I'll be multiplying 4 with -2. So that's what I'll have here. Allow me to complete my workings here. I'll then have that this would be y is equals to -2 into, sorry about that, let me rewrite that one. Y would be equals to -2x squared minus 4x plus 16. I'm multiplying by the negative 2. I'm distributing it using distributive law. So now I have the answer for that one. So y is equals to negative 2x squared minus 4x plus 16. That would be the equation of that particular parabola. Right. I hope you got that one. Now we move on. Second one, now it is still a parabola. We want to find its equation, and also here the examiner was quite clear with us to say determine this equation in this form. Y is equals to ax squared plus bx plus c. So the form there is stated, so we need to then see how best we can solve this one. Now when you check this particular parabola here, you are given, instead of being given the x-intercepts, you are now given the turning point. You are now given the turning point. So if you are given the turning point, then it means you are using the different form. You must use the turning point form of a parabola. Now the turning point form of a parabola is given by a into x plus p squared plus q. That would be the turning form, the turning point form of this parabola. Now, where we know that now, if we are given that form, minus p and q are the coordinates of the turning point. Minus p and q are the coordinates of the turning point, which means you know your abscissa are there is negative p, and you know your ordinate there, which is negative 5. So what we're going to do here, we're going to substitute now. So this would be y is equals to a into, I'm going to start by substituting the turning point, and then I'll substitute the additional point which is given there. I have the additional point which is the y-intercept. So I know if I can write the coordinate of this additional point, x is 0 on the y-axis and y is negative 3, like that. So now the first thing that I'm going to do, I substitute on that form. I substitute the turning point first, and then I'll substitute the additional point. But other learners can just substitute everything at once, but I'll do it step by step there. So now this would be x. I know that p, I know that my p is negative 1 there, so it means that now I will substitute the value of p there. I will have that this is my plus 1, like that, because I know, remember when you look at this, I'm given that the turning point is negative 1 and negative 5, and I know in that form, in this form, x plus p is 0, x is equals to negative p, and y is equals to q, which means that I have negative p and then I have q. So I know that negative p is equals to negative 1, which means p equals 1. That's how you find that one. And then q is equals to negative 5, like that. So I can just substitute p is equals to 1. Where I see p, I put 1 squared plus q is negative 5, like that. So that is the first step. But now I want this at a point 0 map negative 3. So this is the additional point that I'm given. So what you call x is 0, y is negative 3. Remember, you should always have something there, two things for you to be able to determine the equation. First one, we had two x-intercepts and a point, and then in this one we have a turning point and a point. So you change the form there. So now if you substitute the point 0 and negative 3, y is negative 3, x is 0, minus 5. So now we can calculate the value of a. So negative 3 is equals to, when you simplify 0 plus 1, you get 1 squared, which is 1. That's a minus 5. So when you transpose the minus 5 there, you get that a would be equals to 2. So that would be when you add 5 both sides of the equation there. So you get that a is equals to 2. Therefore, now you can say, therefore, y would be equals to 2 into x plus 1 all squared minus 5. Now what's important is this. They said you must write it in the form y is equals to ax squared plus bx plus c. Allow me to continue here. So now I'm going to distribute y is equals to 2 into, in my brackets I know I have x plus 1 twice, and then from there I will have that negative 5 like that, so minus 5 like that. So now if you check, what I did was I made sure that x plus 1 squared is represented by what? By 2 brackets, so that I can be able to then simplify them. Now y would be equals to 2 into, this would be x squared plus 2x plus 1. The reason why it's 2x is I multiplied x and x to get x squared. I got plus 1x. I have another plus 1x, and then I have plus 1 when I use distributive law. So that's where the plus 2x comes from. And then I multiply 1 and 1. I get plus 1 and then minus 5 like that. So now I can simplify this. Y is equals to, I distribute the 2. I get 2x squared plus 4x plus 2 minus 5. I'm distributing the 2, I'm multiplying uniformly throughout there by 2. So now I'll get that y is equals to 2x squared plus 4x. Adding the like terms there, I'll get minus 3 like that. So that would be the equation of that function in the form y is equals to ax squared plus bx plus c. So now we can just summarize what we just did. In the first problem, what we did was we were finding the equation or determining the equation of a parabola, but we were given two x-intercepts and a point. So we used the form y is equals to a into x minus x1, x minus x2, because we are given two x-intercepts and a point. So x1 and x2 represent the x-intercepts. Now in the following, in the problem, the next problem now, we're finding or determining the equation of a parabola, but now we were given a turning point and a point. And if you are given a turning point and a point, then you should note that you use the equation y is equals to a into x plus p squared plus q. That's the form that you need to use, where negative p and q, the coordinate negative p and q, represent now the turning point, the coordinates of the turning point. So you substitute the given turning point and a point, you find the value of a, and then you find the equation there. Now we move on. The next one is a hyperbolic form. You know, a hyperbola will always have those asymptotes. It will always have both the horizontal and the vertical asymptotes. Sometimes those asymptotes are equals to 0. Both of them are 0 if it's a standard hyperbola. But in this case, we are given those asymptotes as y is equals to 1 and x is equals to 1. So now you are given the graph alongside passes through x, passes through a point 3, maps 2, where y is 1 and x is 1. Those two represent the horizontal and the vertical asymptote respectively. So now they say determine the equation in that form. So y is equals to a over x plus p plus q. Now what we're going to do is, we know from this form that x plus p is equals to 0, which means that now p would be given by negative x like that. If you want the value of p, it's negative x. So now obviously you are given x is equals to 1 there, which means that p would be negative 1. That's the first thing. And then q would be equals to, here y would be equals to q. Y would be equals to q, which means that q now, q is equals to, you are given y is 1 as the horizontal asymptote, so q is equals to 1. So that's the first thing that I'm going to do. I'll substitute the value of p and the value of q. So y would be equals to a divided by x minus 1 plus 1 like that. So that's the first thing I've substituted there. Horizontal and vertical asymptote, but I need the additional point at a point 3 and 2 where x is 3, y is 2. So I'll basically now substitute the point on the equation to find the value of a. You've seen with the previous two problems that after I've found the value of a, I will then be able to determine the equation of the function. Similarly here, after determining the value of a, I'll be able to determine the equation of that function. So now if I substitute y as 2, a divided by 3 minus 2, I'm substituting x as 2, where I see x I put 2, then this would be plus 1. So if I simplify here, transposing the 1, I get 1 is equals to a divided by 3 minus 2 is 1, like that. 3 minus 2 is equals to 1. So I can multiply both sides by 1. I get that a is equals to 1. So I've already worked out the value of a there. I've already worked out the value of a. I made a mistake here. Let's see. When I substituted, I made a mistake there. Let's just fix that one. I substituted x as 3, but now this one I changed it to 2. That was the mistake that I made. So let's just rectify that one quickly. So I will have that now y is 2 is equals to a divided by, I must replace this x here with 3. So I'll have 3 minus 1 plus 1, like that. So now I've fixed that mistake. So I'll transpose the 1. I get 1 is equals to a over 2. If I multiply uniformly throughout by 2, I get that a is equals to 2. A is equals to 2 instead of 1. So please note that mistake that I made there. Now let us complete our workings here. So now that I know the value of a, I'm just going to substitute everything back. So I will have that y is equals to a is 2 over x minus 1, as I'm substituting that vertical asymptote, and then I have the horizontal asymptote plus 1 there. So now I've worked out the equation of that particular function there. Now we move on. Remember here I substituted the horizontal and vertical asymptote, the value of p and the value of q, substituted the additional point, worked out the value of a, then substitute a, p and q into the original equation so that I can find the equation of this unique function there. Now the last one here is it's an exponential one. Now I want you to use the knowledge that I've just given you. I want you to use that knowledge into finding or determining the equation of this exponential function. I am going to give you 3 minutes there, 3 minutes. So I'll just read the question for now. 1 and 6 is a point on the graph. Y is equals to, and 1 and 6 is a point on the graph, and y is equals to 2. That's what you are given. Is the equation of the horizontal asymptote. So you are given the horizontal asymptote. Determine the equation of the function in the form y is equals to 2 to the exponent of x plus p plus q. Please try that one out in 3 minutes, and your time starts now. Right, welcome back. Now, hopefully you were able to work out the equation of this exponential function. Let's try to do it together and see whether you manage to get it correct. A point 1 and 6 is a point on the graph, and y is equals to 2 is the equation of the horizontal asymptote. Determine the equation of the following function in the form y is equals to 2 exponent x plus p plus q. Now, when you look at this, you know that in this form, y is equals to a times b exponent x plus p plus q. The horizontal asymptote y is equals to q from the general form, and to find the vertical asymptote, we are then going to equate this to 0, so we get that x is equals to negative p. Now we check what is given. If you check here, we are given that horizontal asymptote y is equals to 2, so we know we're going to substitute it there to get the value of q, which means that first things first, y would be equals to, in this one, y would be equals to 2 exponent x plus p and then plus 2. Where am I getting the 2? The 2 is that horizontal asymptote there. That is the vertical shift there. That is the vertical shift of that particular function. Now, you can see that here, what we need is only now the horizontal shift p. After getting p, then we know the equation of this function. Now let us substitute that given point. We are given a point 1 and 6, so at 1 and 6, x is 1, y is 6. So where we see x on that standardized form there, we're going to put 1, and where we see y, we're going to put 6. So for y, we put 6, 2 exponent 1 plus p plus 2. Transpose the 2, we get 4 is equals to 2 exponent 1 plus p. And then we write 4 as prime base, as a prime base, or as a base of 2. Its simplest base is 2 there. 2 exponent 1 plus p. So it's important for you to know how to solve exponential equations. Remember, grade 12s, you cannot divorce algebra with functions. You should always know that when you learn algebra, you learn the algebra to be able to marry it with functions and be able to marry it also with all the other topics in mathematics. Algebra is a basis for all mathematics. It's important for you to understand your algebra thoroughly. So you see now, I am simply solving an exponential equation here. Right, so now if the bases are the same, the exponents are equal. So if the bases are the same, we equate the exponents. 2 is equals to 1 plus p, then p is equals to 1, like that. So it's very, very important that you know and you understand your algebra. Please go back to your algebra and make sure that you practice it, and you practice it thoroughly. Now let's complete our problem here. So we have that y is equals to 2 exponent x plus 1, because we got p, and then plus 2, like that. So that would be the equation of this exponential function there. Now we are done. We move on to another concept, but before we move on, let us just recap on what we've done. We determined the equation of a hyperbolic function, a parabolic function, what you call an exponential function. So those three functions, we were able to work out their equations. How did we do it? We looked at the form. What was important was that we work out or calculate the value of a, which then gives us the function back, which means it's important for you to know the parameter a, the parameter p, and the parameter q, so that you'll be able to determine the equation of each function. Remember, we cannot also leave out a linear function. A linear function in the form mx plus q plus c, or y is equals to ax plus q. you also should know how to determine the equation of this linear function. In most cases, you will need to then first find m or a by using y2 minus y1 over x2 minus x1, because those represent the gradient of the function, and then from there you will use the additional point. You substitute a given point to be able to then determine q or c. Then that would give you the equation of a linear function. Unfortunately, it was not included in the presentation, but it is something that you've done in grade 10 and you've done again as well in grade 11 and also in analytical geometry. So, but it's important also that you are able to work out the equation of a linear function. Right, we now move on to x y intercept, x and y intercept, horizontal and vertical lengths or distances. Now let us check the summary there quickly. For x intercept, we substitute y with 0 and solve for x. Very, very important. For y intercept, we substitute x with 0 and solve for y. That would be the dual intercept method. Now horizontal length or horizontal distance, for you to calculate any horizontal length or distance, you are going to say that you are substituting x on the right, you subtract x on the left. So you always start on the right and then you go to the left. Also, when you look at the vertical distance between points, you will always start with the y top minus y bottom, the y value at the top minus the y value at the bottom, or the bigger y value minus the smaller y value, the bigger x value minus the smaller x value there. So to find the average gradient, I did actually write down the form there. It is in the formula sheet. It is y2 minus y1 over x2 minus x1. It can also be determined there in functional notation, f of x2 minus f of x1 over x2 minus x1. Remember, f of x2 is y when x is equals to x2, and f of x1 is y when x is equals to f of x1, or when x is equals to x1, like that. Right. Now let us look at the application of this table, the table that I've just given you for x-intercept, y-intercept, horizontal and vertical lengths, as well as the average gradient. But remember, there is also a diagonal length, like that, a diagonal length. It can be like this or like that. That would be a diagonal length. But here you are talking horizontal length, like that, or you are talking vertical length, like that. But you can also have your diagonal length. If you have a diagonal length where this point is given by x1, y1, and this one is given by x2 and y2, we should note that to find the diagonal length d, we are going to use now the distance formula, x2 minus x1 all squared plus y2 minus y1 all squared. You know that you've done it in analytical geometry, and you've also done it in functions there. That is how you find a diagonal length there. If it's not horizontal nor vertical, it is diagonal, then you use a distance formula there. Now we move on. The functions f of x is equals to negative x squared minus 2x plus 3, and g of x is 2x plus 6 are drawn, with g passing through e. Can see there it's passing through e, c, and a. That is the linear function there. F cuts the x-axis at a, b, and cd is the axis of symmetry of f. G cuts the y-axis at point e. Right, determine the coordinates of A, B, and hence the length of AB. Now let's look at A and B. A and B. If you look at A and B, they represent the x-intercept of what? The parabola. But A is a common x-intercept because it is both the x-intercept of a parabola and an x-intercept of what? Of a straight line. So how do we find the x-intercept? I'm indicating here that A and B are the x-intercepts. they are the x-intercepts of what? Of f. If they are the x-intercept of f, how do I find the x-intercept? X-intercept, I let y to be equals to 0. So that's how I find the x-intercept. Now that I've identified that they represent the x-intercept, I'm now going to put y to be equals to 0. So I have 0 is equals to negative x squared minus 2x plus 3. I divide uniformly throughout by negative 1 to standardize this. I have x squared plus 2x minus 3 is equals to 0. I can factorize this. I look for the factors of 3, 3 and 1, and then that would give me 2. I would have plus 2 minus 1 there. Remember also, when you get to this line here, my learners, there's no need for you to actually factorize. If you are not comfortable with factorization, you can use any method of solving for x. You can use a quadratic formula there to find those x values, but you can also factorize there. So if I factorize, I get that x plus 3 and x minus 1 are the factors. So I'll have that x is equals to negative 3 or x is equals to 1. I'm using the zero factor law there to equate the first factor to 0 and the second factor to 0, and hence solve for x. Now I'm going to locate the point negative 3 on the graph and the point 1 on the graph. Now when you look at the graph, you can see that point A is negative, which means that the negative value is for point A and the positive value is for point B. Now the coordinates of A will then be negative 3 and 0, because y, you said you let y to be 0. And the value or the coordinates of B would be 1 and 0 there, which means we can then find the horizontal length, what? AB. What would be the length of AB? X on the right minus x on the left. My x on the right is 1 minus my x on the left, which is negative 3. Remember, I'm putting it in brackets there because it's negative. So the length AB will then be 4 units like that. It will be 4 units like that. So we've worked it out. Now we move on. Right, on the next one, they say determine the coordinates of E and hence the length of OE. So we are looking for the coordinates of E and hence the length of OE. Now, if you look at E there, you can see that E is a point where the graph of G intersects what? The y-axis. It is the y-intercept. So E is the y-intercept. It is the y-intercept of what? Of the graph of G. So how do you find the y-intercept? You say now y-intercept, I put or let x to be equals to 0. I'm using the dual intercept method here. So for y-intercept, I put x to be equals to 0. So where on the graph of what? The graph of G, because it's a point that lies on the graph of G. That's very important. So now where you see x on the graph of G, you are going to put 0. So it's 2 into 0 plus 6. So y is equals to 6, which means that would be the y of E. So it means that the coordinates of E would be, I said put x to be 0. So when x is 0, y is 6. So I have that the coordinates here, when x is 0, y is 6. The coordinates here at O are 0 and 0. And they are looking for, allow me to work out the solution here. They are looking for the length of OE. So OE, you can see that it is a vertical length. So to find the vertical length, I'm going to say y top minus y bottom. Y top minus y bottom. So y top is y at E minus y bottom, that is y at O. So y at E is 6. Y at O is 0. So OE is 6 units like that. So I took y value at the top minus y value at the bottom. That's very, very important. Right, we move on. Determine the length of CD. Let's look at CD. Determine the length of CD. Now, if you look at CD, CD is also a vertical length. CD is also a vertical length, which means you want y at the top minus y at the bottom. Now, let's check whether we have the coordinates of points C and D. Unfortunately, all the workings that we've done, we haven't determined the coordinates of either C or D. So let's check now. CD from the given information is the axis of symmetry. So you know that the line CD is a line that cuts the graph into two equal halves. So you can find that axis of symmetry. We know that to find the axis of symmetry, we use minus b over 2a, which means that I will then use from the equation of f. Remember, it's a turning point of f. So you'll say C is the turning point of f. How do you find the turning point? You use minus b over 2a. So negative b, that would be negative into negative 2, because this is ax squared plus bx plus c, which means that 2a is negative 1. So this would be x is equals to negative 1. Remember, grade 12s, I said to you the axis of symmetry is the line that cuts the graph into two equal points, which means the line of symmetry is the midpoint. I can also use the fact that it is the midpoint. I can say it's the midpoint between point A and point B. Then I'm going to use the midpoint formula that you learn in grade 11 when you do your analytical geometry, as well as in grade 10. So this is now, I can substitute A. The x value at A, we worked it out as minus 3. Here we worked it out as 1 in the previous slide. So minus 3 plus 1 divided by 2, you still get negative 1. You can also use the completion of the square. Later this year, when you've studied calculus, you'll see that you can also use calculus. Now, we found the axis of symmetry. This is an alternative option. You note that this is not an addition to what I did there. It's just an alternative way. So now I know the value of x at the turning point. So I need the value of y. To find the value of y, I'll need to substitute x back into the original equation. So I will have that this is negative into negative 1 all squared minus 2 into negative 1 plus 3. Obviously, I can use a calculator now to put all those things there, and then if I substitute everything on my calculator here, I get that this is equals to 4. I get that y is equals to 4, like that. That's what I'm getting there, which means that I can come here and say the coordinates of C are, when x is negative 1, y is 4. But now I also need the coordinates of D. I also need the coordinates of D because they are looking for the length of CD. So to find the coordinates of D, I know that the x value on the vertical line is the same. I know that on this line, x is equals to negative 1, which means that x at D is also negative 1. But y at D will now be 0 because point D lies on what? On the x-axis. We know on this line, y is equals to 0 everywhere here. Now, I want the length of what? CD. CD would be y top. What is the y value at the top? That would be the y value at C, because C is the one that is above y top minus y bottom. So I'm taking the y value at C, subtract now the y value at point D. So the y value at C is 4, subtract the y value at D, which is 0. So the length of CD is 4 units. The length of CD is 4 units. Right, we move on, grade 12s. Right. The next one, they say calculate or determine the length of CE. Now, I've attached the coordinates of all the other points now. We are looking for the length of CE. Remember, we've calculated the coordinates of E, we've calculated the coordinates of C, the coordinates of A, and the coordinates of B. Now, if you look at the length of CE, if you look at CE, CE is not horizontal, CE is not vertical, but diagonal. It's a diagonal length. And I did indicate that if you have a diagonal length, you are going to use your distance formula, 0 and 6. So because this length is diagonal, I'm going to use the distance formula. CE would be the square root of x2 minus x1, x2, y2, x1, y1. x2 minus x1 is 0 minus negative 1 squared plus 6 minus 4 all squared. So that is the substitution thereof. So this would be the square root of 5. CE would be the square root of 5. If you put it in your calculator, then you know the length of CE. Right, good people, we've worked out horizontal length, x on the right minus x on the left, vertical length, y top minus y bottom, diagonal length, the distance formula. That's what we learned on the previous 3 slides. Right, we move on now to transformations. We move on to graphical transformations, where now you are going to be taking a graph. It's either you move it to the left or to the right, or you reflect it about. Now when you reflect it about the x-axis, if these are your x-axis and there was a point there, reflecting that point about the x-axis will give you now a new point that would be a reflection of that point, but now on the x-axis, so you get a point there. If you are reflecting a point on the y-axis, if you had a point here on the left hand side, that point would be reflected along the line. It will then appear now on the right hand side. You can also reflect about the line y is equals to x. That's what you will be doing this year. When you find the inverse, you'll be reflecting about the line y is equals to x. That would be your reflection. You can also have what we call now the translation. Translation, it's either you are moving the graph up, or you are moving the graph down, or you are moving the graph to the left, or you are moving the graph to the right. So that would be your transformations there that we're going to be looking at. Now in the table there, I've summarized the transformations. First things first, I've looked at the translation that will involve horizontal movement, moving the graph from right to left or from left to right. That would be the horizontal translation. You can also have now the vertical translation, moving the graph vertically up or vertically down. Very, very important there. Now, let's check what happens. If you have a point and you want to move it in the x-axis, what you do is to translate the point, the vertical shift of that point. To get the vertical shift, what you simply do is, if you had a point here, maybe this point was at -1, and then you have 0, 1, 2, and you want to move this point 2 units. Remember, this point has the coordinate -0 and -1. If you want to move it 3 units up, it's 1, 2, 3, then this point will end up here at 0 and 2. If you check, nothing happened to the x value, only the y value changed. That is why here on y we add q, because only the y value changed. In the whole, if you want to move the whole function, then you're going to take the equation of that function f of x, and then you're going to add q to that. So what happens is, what is the rule? A constant q is added on the function formula. Very, very important. And then what happens? You take, to get the new y value, you take y old and you add q. That is where now you say to get g of x, you take f of x, you add q. What is the effect on the graph? The graph moves up when q is positive. It moves down when q is negative. The graph shifts in accordance to the sign of q. Now, let's look at the horizontal movement. Now you want to move to the left or to the right. What you do is you are going to add p on the x because you are moving horizontally, which means that you are transforming the graph on the horizontal axis. Now also, if you're moving the whole graph, that is, if you move a point, I'll give an example here. If you move a point, you have 0, 1, 2, you have 1, you have a point here, 1 and 2, and then this is 3, 4, 5, 3, 4, 5. Now, if you want to move that point horizontally, what happens is, suppose that you want to move it 2 units to the left, you'll say 1, 2. Now, what will happen? The new point will now be given by, the new point would be, oh, I made a mistake here with the old point. Let me write it again up here. The old point here was given by x was 2 and y was 1. So x was 2 and y was 1. Now I'm moving it horizontally by 2 units, which means 1, 2. So it gets to 4. So this point here would be 4 and 1. If you check, the value of y remains the same. Nothing happens to the value of y because you are moving only horizontally. So x is replaced by x plus p in the function formula because it was f of x. Now it is f of x plus p. What happens? You substitute x plus p where you see x. Now, what is the effect on the graph? The graph shifts to the left when p is positive. The graph shifts to the right when p is negative. So the graph shifts opposite to the sign of p. Right. Now, let us look at the translation. Translation or reflection, I should say. This was translation. Now, let us look at reflection. Now, reflection, if you reflect about the x-axis, what happens is y becomes negative. If you are reflecting about the x-axis, this is the x-axis, and you are reflecting a point that was here, the point would come down here. So the point will have the same x value, but the y value will change the sign. If you are reflecting about the y-axis, the point that was here will be reflected this side. So which means that the x value will then become negative, or it will change the sign. The x value will change the sign. If it was this side, it will be that side. If it was this side, it will be that side. But the value of y remains the same. So that's what is important. So now, if you check here in the function notation, you will replace f of x with negative f of x. Now, if it's the horizontal movement, you will replace x with a negative x if it's reflected on the y-axis. If it's reflected on the x-axis, y becomes negative. If it's reflected on the y-axis, x becomes negative. So I explained it here. Y becomes negative y, g of x becomes negative g of x. Now, what happens if it's reflected in the y-axis? X becomes negative, so g of x is replaced by f of negative x. The graph flips about the y-axis, the graph flips about the x-axis, right? Those are the transformations that we are going to cover for now. So let us look at these transformations. Let us try applying them to problem solving. Right, given the function f of x is equals to 2 exponent x minus 1, in each of the following cases, determine the equation of g. That is the first thing. G. Remember, you are given f. Determine the equation of a new function g and describe the transformation from f to g. You then need to describe what you did to f to get to g. So let's look at the first one. G of x is equals to f of x minus 3. So when I see f of x, I'm going to put 2 exponent x minus 1 and then minus 3. Remember, this was my f of x. This was my f of x. So I substituted f of x there by 2 exponent x minus 1. Now, if I simplify this, I get that g of x would be 2x minus 4. 2x minus 4. Now, what happened there? What happened to f? Remember now, f was 2x, 2 to the exponent of x minus 1. What is g now? G is 2 to the exponent of x minus 4. What is the change that you see? You can see the change occurred on the value of what? Q. The change occurred on the value of Q. What happened? You moved from minus 1 to negative 4. You moved from negative 1 to 1, 2, 3, 4, negative 2, negative 3, negative 4. So you moved from negative 1 to negative 4. So how many units did you move? 1, 2, 3 downwards. You moved 3 units downwards because this value changed from negative 1 to negative 4. So you're going to say f is shifted 3 units downwards to obtain G. F is shifted 3 units downwards to obtain G. That's basically what happened there. Now, let's look at the next one, B. Let's look at the next one, B there. Now, we are given G of x is equals to negative f of x minus 1. So, negative, where we see f of x, we should now have a negative f of x minus 1. So where we see x, we're going to put what? Substitute and replace x with x minus 1. So this would be 2 exponent. Where we see x, we put x minus 1 and then minus 1. And then from there, plus 2. So g of x is equals to negative 2 exponent x minus 1. And then plus 1 plus 2. So g of x is equals to negative 2 exponent x minus 1 plus 3, like that. Now, if you look at this, you compare with f of x is equals to 2 to the exponent of x minus 1. You see now there are many changes that occurred. There is a change here. Instead of a positive, there's now a negative. There's a change also. Instead of negative 1, there's now a 3. There's a change also. Instead of x, we have x minus 1. So this transformation occurred in the 3 different ways. So we need to be able to describe it. Now, what is the transformation that changes f? That changes what? F of x to negative f of x. It is what? The one that changes y to negative y. It's the reflection in the x-axis. It's the reflection in the x-axis. So we're going to say f is reflected in the x-axis. That is number 1. What is the transformation that changed x to x minus 1? It's a horizontal translation. Then moved 1 unit to the right. Then moved 1 unit to the right. And how many units upwards? You see here it has a shift of what? Negative 1. The value changed from negative 1 to what? To positive 3. So it means you went negative 1, 0, 1, 2, 3. From negative 1 to 3, it means you add 4. So what did you do? And 4 units. 4 units upwards. So those are the transformation that occurred here. F was reflected in the x-axis. moved 1 unit to the right, and 4 units upwards. Good. That's what we basically did for that one. Now, let's look at another example on the transformations. Now, given the function f of x is 2 over x minus 1 minus 2, write down the domain and range of h if h of x is f of x minus 1 plus 3. Now, what is the transformation that occurred here? The transformation was from f to h. What happened? X minus 1 is equals to 0, x is equals to 1. So we moved 1 unit to the right. What also happened here? We added 3. So we have that we have to add 3 there. Y is equals to what? 3. So we move 3 units upwards. Now the question is, what is the domain and range? If we are to find the domain and range of f, then we transform them. Then we will be good to go. So to find the domain and range, what is the domain and range of f? Domain of f. What would be the domain of f? X an element of all real numbers, but x cannot be the asymptote 1 there. So what is the range of f, the original function? Y an element of all real numbers, but y cannot be negative 2. But they don't want the domain of f and the domain of g. They are looking for the domain of, they are not looking for the domain and range of f, they are looking for the domain and range of h, which is a new function that was transformed. So now what we do is, we know we've moved 1 unit to the right. So what we're going to do is, to the domain of g, we're going to move it 1 unit. To the domain of f, we're going to move it 1 unit to get to the domain of g. So x cannot be equals to 1 plus 1, which means that x cannot be equals to 2. What I did there was, I moved by 1 unit to the right. Now, what is the range of f? The range or domain of g here, range of g. It's y an element of all real numbers, but what happened is, cannot be negative 2, but you moved it up, so it cannot be negative 2 plus 3, so y cannot be equals to 1. So that's what we did. Remember, there's another way of doing it. You can find the equation of h. Sorry, I'm using g here instead of h. You can find the equation of h first, and then you can get the domain and range from that specific equation. Right. Now there's another one. This one is the function defined by R. I am going to actually give you 3 minutes to work this one out, and I have faith that you are going to get this one correct. I'll just read the question for you before giving you the 3 minutes. In another function, R is defined by R of x is f of x minus 3 plus 7. Determine the coordinates of the point of intersection of the asymptotes of R. So you have 3 minutes to try and solve that one. Your time starts now. Right, welcome back, grade 12s. Let us look at this one. We will try to do it as quickly as we can. Obviously, you've worked it out, and I hope that you'd get the same answer as I would. Right, I'll try to do this in both the methods. Now, if you check the movement here, the movement or the translation was x minus 3 is 0. So x is equals to 3. And also, I'm taking it from here. And also y is equals to what? 7. So it has moved 3 units to the right and 7 units upwards. All the points in this function have done that. They've moved 3 units to the right and 7 units upwards. All those points. Now, we are interested in the coordinates of the point of intersection of the asymptotes of R. So those coordinates were -1 and, not -1, it was 1 and -2. Those were the coordinates of the original function f. Now what has happened? The whole function has moved 3 units to the right, 3 units to the right, and moved 7 units upwards. So all the points have done that. They've moved 3 units to the right and 7 units up. So it's 3 units to the right and 7 units up. So the new point would be 4 maps 5, like that. 4 map 5. Alternatively, I said grade 12s. Another method of doing this would be to find the new equation, the equation of R, and determine the asymptotes from R. Remember, these asymptotes, we determined them from this equation. X minus 1 is 0, x is 1, and y is -2. That's where we got this point. Now, if we can find the new equation of R and then find the coordinates from that. So we are going to then say R of x would be f of x. So where I see x, I put x minus 3 and then -1. -2, where I see y, I put 7. So the equation R of x would be 2 over x minus 4. -2 plus 7, I'll get plus 5. So from here, I can then be able to say x minus 4 is 0, x equal 4, and y equal 5. Therefore, the coordinates would be 4 and 5. So if you check, that one is the same as this one. So that's another way of determining the new point after transformation has taken place. If you have an equation, you can determine the equation of the new transformed function and get the points from the new equation. Alternatively, you can check the original point. What is the original point? Knowing the original point, like I did here, I would then say, but I also know how much that point has moved. I move that point and then I get the new point. That's a way of getting it like that. Now, let's look at the last part of our lesson for today. We are looking at inequalities now. Applying the concept of inequalities, but only using the graphical approach. Now, the first important thing here would be the notation. Remember, we're going to use the round brackets for not included. We're going to use the square brackets for included. And then also in the notation, we use an open interval for not included, and we use a shaded interval or shaded dot. We use a shaded dot to show that the values are included. Right, let's move on. The first part of the interpretation thereof would be those solitary functions. If you have a graph that is drawn on its own, it's not on the same set of axes with another graph, it's just on its own, you are going to read it this way. If they say f of x is greater than 0, they are trying to say y is greater than 0. Where is y greater than 0? This would be y equals to 0 or your x-axis. So where is the y values greater than 0? Where are they greater than 0? The y values are greater than 0 here. Here. So what is this region? Is the region above what? Above the x-axis. It's the region above the x-axis. Where is y less than 0? It is the region what? Below what? The x-axis. It is the region below the horizontal or below the x-axis. So if they say f of x greater than 0, you're going to look at the graph. Try to find a portion of the graph that is above the x-axis. If they say f of x less than 0, you find the portion of the graph that is below the x-axis. Right, if they say f of x is equal to 0, you find the portion of the graph that is exactly located at the x-axis. Right. Now we go to inequalities, comparisons. Now we are going to now be looking at two functions or more that are sketched on the same set of axes. Remember here, we were looking at only one function on its own in its set of axes. But now you are looking at two functions that are sketched on the same set of axes and you want to compare them. That is the comparison. You want to see where one is above the other and where one is below the other, or where they are at the same position. So you want to compare what? Their positions. At the same position, the other one above, the other one below. That's what you want to do. So we are saying when they say f of x is equals to g of x, that is where they are at the same position. That is where they are equal. The y values are equal. That is where they intersect. F of x above g of x. So they are saying the y value of graph 1 is greater than the y value of graph 2. That is what it means. But because we name functions using functional notation, f of x and g of x, so we are going to call y of graph 1 f of x, y of graph 2 g of x, and this means greater than, or above. So we are going to locate the region where the graph of f is above the graph of g. Now here we locate the region where the graph of f is below the graph of g. Now here we are now going to locate a region. This one is very, very important. F of x minus g of x is equal to 1. We are going to locate a region in space or a point on the graphs where f is above g, because it's f minus g, where f is above g, and the vertical distance between f and g is 1 unit. Very, very important. F is above g and the vertical distance between f and g is 1 unit. That's very, very important. Now, note this one as well. F of x minus g of x is equals to 0. This does not mean f is above G and the distance between them is 0. No. If it is given by 0, then we transpose, we get f of x is equals to g of x. Now, where is f of x equals to g of x? At the point of intersection. So if they equate them to 0, you transpose, and then that's where you're going to get the region in space. Right, the last part would be now the combinations. Now that is where you are going to be looking at where both graphs, you no longer looking at one, like in the solitary functions here. When I say in the solitary functions, the graph of f is above and the graph of f is below. Now you are going to be looking at both f and g being above or being below. So it is important to first note here the reference f of x times g of x is equals to 0. This is where f of x is equals to 0. Also, it occurs when g of x is equals to 0. For this product, f of x times g of x to be 0, either f would be equals to 0 or g would be equals to 0 or both. I repeat, either f would be equals to 0 or g would be equals to 0 or both. Now that would be the point of reference. If you multiply the two, f times g, you are looking at a region in space where both f and g are above the x-axis or both f and g are below the x-axis. Now note this one now. We started to divide. Remember, in any algebraic fraction, once you started to divide, you bring along a natural restriction. Because once you divide, if I divide 2 by x, if x is equals to 0, 2 divided by 0 is undefined. So naturally, when I have an algebraic fraction, when I have a division there, the denominator should never be equals to 0. So I bring along that concept here. F divided by g, I'm saying note the restriction. G should not be equals to 0 because a fraction, when the denominator is 0, becomes what? Undefined. It is undefined, right? Now let's look at this one now. X times f of x is greater than 0. It simply means now you are comparing or you are combining the x-axis. This x represents what we call now the x-axis. We are now comparing the x or combining the x-axis with the graph of f. And you want to find a region where the x-axis and f are both positive or both negative. That's why here I'm saying positive x-axis and the graph of f above the x-axis, or negative x-axis and the graph of f below the x-axis. Right, let us apply this, because when we preach it out, we become preachers, right? And as mathematicians, we are not preachers. We are problem solvers. Let us see now how we can apply those notes to problem solving. Given the functions f of x is x squared minus 2x minus 3 and g of x is x minus 3, a is negative 1, 0, b is 3 and 0, c is 0 and negative 3, d is 1 and negative 4, are the coordinates of the x, y intercept and the turning point respectively. Now determine the values of x for which f of x is less than or equals to 0. We are only focusing on f. Remember, we are given the coordinates here, negative 3, 3, and then, or negative 3, let me see, oh no, it's negative 1 here, negative 1, and then 3, and then all here we are given 0 and negative 3, here we are given 1 and negative 4, like that. So now they are saying the graph of f. So here we know they want where f is below the x-axis. Where is the graph of f below the x-axis? Let us note that we want to find where the parabola f is below the x-axis. Check what I'm highlighting. This whole portion of the graph, this region is below the x-axis. What is that region defined as? It is the region between what? Between -1 and 3. So this occurs when x is between -1 and 3 included, because they said below or at the x-axis. Now let's look at the second one. It says G above the x-axis. That's how we interpret it. G above the x-axis. So how do we get the region where G is above the x-axis? We locate the graph of G. Check what I'm going to highlight. I'm highlighting this portion because that is the portion of the graph that is above what? The x-axis. So this region here of the graph of G is above the x-axis. It's a region starting from 3 going that way. 3, 4, 5, 6, and so on. So starting from 3 going to the right. So which means that it's values that are greater than 3. 4, 5, 6, 7. Those are the values that are where the graph of G is above the x-axis. Now the graph of f is increasing. The graph of f is increasing. So we are dealing with increasing and decreasing function. So when does the graph increase? It increases when the gradient is positive. It increases when the gradient of the graph is positive. Now let's locate the gradient of this function. This side, if you look at this side of the graph, the gradient is negative. At the turning point, the gradient is positive. So this is what is happening. The gradient is negative. At the turning point, the gradient is 0. After the turning point, you can see the graph is now increasing. So the gradient is now positive because the x values are increasing. We say the gradient is positive where the x values are increasing and the y values are increasing. So we say it's an increasing function because both x and y are increasing, or the gradient is positive. So the x and y values are increasing after the turning point, which means that f of x is increasing when x is greater than 1. When x is greater than 1, after this point 1, you can see that the portion of the graph is now increasing because this was the graph here, x was 1 here. Here it is decreasing and here it is increasing. Here it is 0. The gradient is 0. It is not increasing nor decreasing. We say that it is stationary. You'll learn more about this as you go on with your mathematics syllabus. Right, we move on now. Let's look at the next one now. Determine the values of x for which, obviously we are given these points here, -1, 3, 1 and -4. This is -3. Now they are saying f of x minus g of x is less than 0. So here it's two functions. I said to you, you are going to transpose if it's like that. F of x less than what? G of x. So f is below g. So now when you want to compare functions, I will always recommend that you draw vertical lines where they intersect. So the graphs intersect here. I'm going to draw a vertical line. The graphs intersect here as well. I'm going to draw a vertical line. So what do you see now? My vertical line that I've drawn is at what? -3 and what? And it's at -1 and 3. Both of them are not included. So I have my boundaries where the graphs are intersecting. So now I'm going to read the graphs from left to right. From this side, I'm going that way. I want to locate the region where the graph of F is below the graph of G. That's what I want. F is below G. So I'm going to check. Now look at the first vertical line. Check the graph on the left. Which graph is above? Check now. This is F. F is above, G is below. What am I looking for? F is below. So I'm not interested. The answer is not here. Now let's check in between the two vertical lines. In between these two vertical lines, what do you see? G is this one. G and F is this one. Can you see that now F is below? G is above, F is below. So it occurs in this region. I'm okay with that region. My answer is in that region. Let's check whether on the other side we can also have a solution. This side you see F is now above. There is G. G is below. And you are looking for the region where F is below. So that region is the region in between the points of intersection. It is this region here when X is in between -1 and 3. When X is trapped between -1 and 3. Now, let's look at this one. G of X minus F of X is equals to 2. G of X minus F of X is equals to 2. Now here we are looking at a region where G is below, or G is above F, and distance, this is a vertical distance. And the vertical distance between F and G is 2 units. So we are looking at the region where G is above F and the vertical distance between them is 2 units. Now I will answer it on this next slide because that graph is now not visible. Let me put on the points here. They were looking for G of X minus F of X is equals to 2. I'm putting the points -1, 3, -3, and then 1 and -4. So I want a region where G is above F and the distance between them is 2 units. Now, if I locate the graph from left to right, I will try to find where the graph have the biggest distance between them. Now, if you check, the distance between the graphs here starts to increase. And then as you go, it decreases. So if you look at the axis of symmetry, check on the axis of symmetry. What is the y value of G at the axis of symmetry? X is 1. If you are to substitute G of 1, you get 1 minus 3, you get -2. -2. And then if you are to then substitute it here it's -2. So you can see that on the axis of symmetry, when X is equals to 1, I have that on the graph of G, I have -2. On the graph of F, I have -4. The graph of G is G here and F there. Now, if you look at the distance between the two, the vertical distance, what would be the vertical distance? Y top minus Y bottom. What is Y value at the top? -2. Y value at the bottom? -4. So what is the distance here? 2 units. So you can see along this line, the distance is 2. Along this line here, the distance is 2. And it is true, G, the straight line, is above and the parabola is below. So it occurs along this line. But the question is, for which values of X? What is the X value along this line? It is what? X is equals to 1. So I'll go back here. It occurs, this answer here occurs when x is equals to 1. That's where g is above f and the distance between them is 2 units. Remember, grade 12s, you need to practice these inequality problems thoroughly for you to understand them. Right. Grade 12s, we've run out of time. The last two portions that were remaining, we are going to continue with them in our next lesson. In our next lesson, we are going to make sure that we integrate or we connect with this lesson so that it becomes a continuous lesson on the interpretation. So wherever I stopped today, we are going to continue next week on that vein. But now the summary here of this lesson is that we learned that we can determine the x and y intercept as well as write the equations of the functions. We determine the different equations of all these functions. We worked with horizontal and vertical lines. We worked with the concept of transformation, and we were able to solve some inequality problems. That's basically where our objectives for today. Right, grade 12s, thank you very much for watching and for tuning in. Please make sure that you practice your mathematics. You practice every day. You practice as much as you can. For now, it's time up. We are loving and leaving you. Take care of yourselves. Take care of each other. Practice mathematics. Bye-bye.